Hi, I'm Joe Gordon. I'm Chairman of Economic Development for the town of Branford. And today I'm privileged to have a guest who is a prominent local businessman. Jonathan Rothberg and his son Noah are here. And Jonathan is the pioneer of high-speed DNA sequencing, which is a very exciting outgrowth of the discovery of the DNA double helix, which occurred about 20 years ago. I got interested in this subject from this issue of Forbes magazine, which highlights the work that Jonathan has done. He's founded 3 companies in this area and is really cited here as the key person in a $100 billion industry that counts all the offshoots that we expect to come from this. And it's a very exciting science. I think this is the best opportunity for economic growth that I've ever seen. And I thank you for coming here today, Jonathan, and your son also, Noah. And I'd like to start out with have you tell us your educational background, if you would.
I was trained as a chemical engineer at Carnegie Mellon, and was very interested in applying my chemical engineering expertise to biology. I felt that biology would be the frontier for the 21st century, like physics was the frontier for the 20th century. After my chemical engineering training at Carnegie Mellon, I went to Yale and got a PhD with a focus on molecular biology.
Very good. When you, I should also say that your family is very well known in this area, and your family owns and started Laticrete in Bethany, which is a very successful company, and you could have walked in there, sat down at a desk, and enjoyed your career there. What motivated you to go into a really different field of biology?
Well, first, I guess you could say that entrepreneurship was in my DNA. So
Okay.
what I do in sequencing is study the language of life, DNA. And my father was an entrepreneur and started Laticrete, and with my older brothers and sisters, built that into an international business. So what I learned from my dad was that it's not about going into his business, but taking that entrepreneurship and doing what you love. My dad made it clear to me that if I worked on what I loved, I would never work a day in my life.
Very
and
good.
That's been true.
That's been true. You seem to enjoy what you do very much, and I'm just very impressed. I'm an engineer. When I grew up, it was all about going to the moon and the space race and everything. I look at this as much more exciting and much more affecting the human life that people live and their health, and it's got so many applications. I'd like to get into some of those. You're the founder of Curagen and 454 and Ion Torrent, which were all in the business of high-speed sequencing. But you've taken it to a really higher level, according to this article. And I'd like you to kind of expand on what you've done that's so different to affect this industry.
I think the first thing to do is to think about DNA sequencing like you think about medical imaging. So all of us are familiar with going to a doctor and having an X-ray, having an MRI, or having a CAT scan. And what I'm doing is, instead of making an imaging instrument, I'm making an instrument that reads the blueprint or instruction set for life. So most of us are familiar with computers, and we know 1 and 0s make up your computer program. What I have done is I've made a machine that reads the computer program of life. The nice thing about that is, whether you want to heal people through healthcare, you want to understand their genome and make better medicines, whether you want to feed people through agriculture, you want to understand the genome of plants and improve it, or now whether you want to fuel the world, you want to make better fuels through biotechnology and microorganisms. The common thread is all of these things leverage life forms, and to understand a life form, instead of just looking at it and seeing what is, you can read its DNA and get its instruction set. And once you read its DNA, you can make it better, if you want to make an organism that makes fuel, if you want to make a plant that's drought resistant, or if you want to understand a person with diabetes or cancer, you can see what's broken and know how to intervene. So it's like looking at a blueprint for anything you're interested in. Mm-hmm. And that's the power. And it is great. I'm able to get the best people when I start a company because I tell them, you're going to do something that is going to affect the lives of someone you love. Mm-hmm. And very few people can say that. So when you come to work for Ion Torrent now, it's quite motivating because our machines are in major cancer centers. They're at Yale, they're at the National Cancer Institute. They're actually in over 40 countries, and they're helping patients today. Remember that outbreak this summer where people were dying in Germany from an unknown bacterial outbreak? People used our machine in a single day to understand what was causing the outbreak, have a blueprint for the superbug, and then they were able to make a quick diagnostic and screen the food supply. So again, nothing's more rewarding than being able to impact the lives of people you love in the future and right now.
Now, I was interested in the sequencing process. Basically, if I'm not mistaken, involves separating the two halves of the double helix. Is that correct? And each time it breaks one of the, I'll call it rungs. I know it's base pairs, but every time one breaks, it gives off an ion charge. Is that correct?
But that's a great description of our technology, but one of the ways I like describing it is to think about the camera in your phone.
Okay.
And most of us walk around with a phone with a camera, and this camera sees light. What we do at Ion Torrent is we've made a little chip, and that chip is based on the $1 trillion of technology that went into modern electronics. But our chip, instead of seeing light, sees chemistry. And what we do is we see the chemistry that underlies those chromosomes or genes. So if you put an AIDS virus on it, you can read off the 9,000 letters that make the AIDS virus instruction set. If you put the bacteria that was killing people in Germany this summer, you can read off the 5 million letters that are the instruction set for that bacteria. Or if you put a human on the machine, you can read off the 3 billion letters that all of us know are on those chromosomes that are in every cell and determine everything from conception to birth throughout life. And so what we've made is an electronic device that directly sees chemistry. And it was my son, Noah, who first motivated me 10 or 12 years ago to first invent high-throughput sequencing because he wasn't breathing. And I want to know what was wrong with Noah when he was in the newborn intensive care unit. And then a few years ago, I was telling Noah we had sequenced that double helix you talked about from Jim Watson, who was the person that gave us the basis of heredity, how we inherit genes, and how our double helix works. We had just sequenced his genome as the first individual person to have their whole blueprint read off. And I was telling this to Noah, and he said, "Dad, what you really want to make is a machine that reads minds." and instead of rejecting that, I thought about it, and I said, wait a minute, he's right. We need to make a machine that sees chemistry. And that gave rise to the second major innovation in high-throughput sequencing. So our first innovation was great, but it cost $500,000.
Right.
This next innovation, just like the personal computer, built on electronics, is low cost. So we're now selling the machines, along with Life Technologies, around the entire world. And now, for less than $100, you can read off a small genome, like this bug that was killing people, and immediately understand what's happening. And so Noah motivated me twice. Once 12 years ago, as I said, to sequence fast, and then to rethink it and make it portable and inexpensive. And we came out with a personal genome machine and a chip that sees chemistry.
Now, I understand that there's many applications in medicine, but also in pharmaceutical industry where you're trying to discover viruses, how to cure viruses and things like that as well. Is that correct?
Absolutely. One of the first things we did when we invented high-throughput sequencing, and that was done right here in Branford, Connecticut, one of the first things we did is work with Johnson & Johnson, and we helped them make the first new drug for tuberculosis in over 40 years. Because for the first time, we could read the entire blueprint of the tuberculosis drug, read the whole blueprint of the tuberculosis bacteria, and make a drug that would kill it. So that's one of the first things we did when we invented high-throughput sequencing, is we helped Johnson & Johnson, and now every major pharmaceutical company in the world would never think of developing a drug without understanding what it's doing, and that understanding means reading the blueprint. We helped Pfizer with HIV drugs. We helped a number of companies make diagnostics that have turned HIV from a death sentence to a chronic disease. So absolutely, you can use DNA sequencing to diagnose, you can use DNA sequencing to develop drugs. And now people like my wife, Bonnie, who's a professor, assistant professor at Yale, she uses DNA sequencing to tell people when they have cancer, whether, for instance, and somebody is diagnosed with metastatic melanoma, if they're the 50% that are going to progress or the 50% that are going to be okay. So you can actually use DNA sequencing to predict the future. So it's a very powerful tool. And again, that's why I like comparing it to imaging. All of us know how powerful it was when we had a microscope for science. All of us know how powerful it was for medicine when you could do MRI and X-ray and CAT scan. This is a tool, but a tool that gives you the instruction set.
One of the things that I felt bad about when I read this article was how little I had known about what was going on right here in Branford before I read this article. And I thought that one of the reasons why I was trying to set up this interview with you is because I think the average person doesn't realize the enormity of the DNA sequencing or understand the sequencing, the terminology. You hear about it, but it's like what my first reaction was, what do they mean by sequencing? But in fact, you had explained to me that it's actually lining up the separate readings and matching up the ends. Now, what I'm hearing though is maybe that's no longer.
No, that is the description. So again, in every one of your cells, you have these chromosomes.
Yeah.
Those chromosomes are made out of a chemical, and the chemical is DNA, and it has 4 letters, A, C, G, T,
right.
And it's those letters strung together that are literally the instruction set for life. That DNA says what proteins to make, which is the physical things that you interact with. It's the instruction set. And so what we do is just read off the instruction set. The nice thing about biology is there's no new physics, there's no new math. It's conceptually simple. Sometimes there's a complicated vocabulary that keeps people out of the field, but there's no magic. I do want to touch on what you said about Branford. I was able to create a number of companies that have become quite successful in Branford. And one of the reasons is that we have institutions like UConn and Yale, which produce fantastic graduates. And then we have a fantastic military-industrial complex where people have worked with high technology, electronics, and programming. And everything I do and every business I build is based on being in the intersection of biology and engineering. And Connecticut is absolutely at that intersection. And that's why it's been easy for me to hire the smartest people in the world and have them solve really tough problems because we're at that intersection. And there's a great history of that intersection, obviously, right in Connecticut.
Very interesting. Also, I was very interested in your applications in anthropology, where if you want to expand on that a little bit, this is a great story.
So, like many people watching this, I love the movie Jurassic Park,
Right.
where they brought back dinosaurs. In fact, I used to tell my nephews, even before Jurassic Park came out, that someday I wanted to bring back ancient creatures. And so when we first had this tool The first time in the world you can imagine having a telescope, what you would do. Well, for the first time in the world, right in Branford, at 454, we had a tool that could decode DNA 1,000,000 times faster and 1,000,000 times cheaper than anybody before. So we wanted to use it on the most exciting things. And so what I did is I called the most famous person in the world, Svante Pääbo, on ancient DNA, and said, Svante, let's read off the genome of something extinct. Let's read off the genome of Neanderthal. This is the caveman. It hasn't been around for over 40,000 years. Let's read off its genome. And Svante sent me DNA, and in one day in Branford, Connecticut, we had more ancient DNA than had ever been discovered, and we decoded the entire Neanderthal genome. Now, as a business, we sold our machines to anybody around the world. Other people used the machines to sequence the woolly mammoth. And so you can take anything that's gone extinct in the last 100,000 years that you can get a bone or hair from. You can pull out its DNA. Remember, DNA is in every cell. That instruction set is in every cell. And so you can pull that DNA out and you can sequence it. And now dozens of extinct animals have been sequenced. We've sequenced Neanderthal. Recently with Svante Pääbo on high throughput sequencing, they found another ancient man that had been extinct called Devisonian man, and we sequenced that. And it's more than just interesting from a historical perspective. Realize that Homo sapiens, when we came out of Africa, we went everywhere. Neanderthal never crossed a body of water that he didn't see the other side. So there was a huge difference in our ability to explore, our ability to do cave paintings. And so when you have the genome or the blueprint of a Neanderthal, and when you have the genome of a person, you can compare them and you can find out what genes give us that creativity, give us that intellect. So it's been fascinating, so we know where we come from, but it's also fascinating because for the first time, we can understand what makes modern man special.
And what I've read also is that there's a term I'd like you to explain. It's called the expressing how the DNA is expressed.
Again, everything we do in biology is conceptually simple. We have a complicated vocabulary. So if you think about this instruction set that comes with your sperm and comes with an egg, when the sperm and egg come together, you have your human genome. That instruction set then tells that cell how to divide and how to grow up into a beautiful child. Now to do that, those genes have to go on. That's called expressed. And so you can have a light bulb and you have electricity, but it's flipping the switch and turning it on that matters. So what you do is you have an instruction set on your chromosomes. It's turned on, and when it's turned on, it says in every cell what proteins to make. And that's why a hair cell is different than a skin cell or a kidney cell.
Now, of course, everybody knows the importance of DNA in forensics, and a lot of the police and FBI and everybody is trying to really increase that. There's a tremendous backlog and demand for sequencing DNA just in the law enforcement. So you're bringing this cost of this process down is certainly going to, I think, explode into many businesses, all over the country. That's very exciting.
Absolutely. Torrent is now part of Life Technologies, which is the world leader in forensics. And in the last few months, these are exactly the conversations we're having. How can we make it cheaper and more accurate to use DNA sequencing in forensics and use it in fields that we haven't talked much about yet? As I mentioned, agriculture. We have 7 billion people on this planet now. We have to feed them. We all want to drive cars and fly in planes. How do we make those fuels? In each of those cases, DNA sequencing is improving our ability to grow drought-resistant plants that yield more, to make bugs that make fuels. The first jet planes have now flown across the Atlantic with fuel that was made in a bug, if you will, and that bug was engineered by DNA sequencing.
Very interesting. The conversation we had before, you were talking about government research and how important it is to what you're doing. And I'd like you to kind of talk about that for a moment.
I think this is critical. You hear a lot of discussions, especially now, about who we should tax and how we should tax. But no matter how you tax and who you should tax, you still have the same amount of beans and you're just moving the beans around. All wealth comes from technology, and all technology comes from research. And governments, for the last 2,000 years, have actually done two things really well. They've sponsored research, whether it was into aqueducts to give us Rome, or research into getting to the moon that gave us all of this modern electronics. So at the highest level, you can say that it's research that gives us technology, that gives us high standard of living. We now can live to 100 because we have clean water. Again, research. But so that's at a high level. I'd like to make it more personal. So I told you I started my first company in Branford. The way I started that company was through grants. I wrote, and with my early team, we received over $15 million of funding. And so, again, it's nice to say conceptually, all wealth comes from that research and technology. None of us would have cell phones, none of us would have the internet, none of us would have friends with pacemakers, none of us would have MRI if we didn't do basic research. And it was the National Institute of Health that has focused on research and health. But more specifically, my companies wouldn't be here if we didn't have the ATP program for advanced technology, if we didn't have a program that says, at the government level, we want to fund DNA research. So again, no matter what your political persuasion, no matter what you think about taxes, it doesn't change the number of beans. If you want to raise the standard of living, you have to do research. If you want to have companies that create jobs, you have to have research. So my success comes from that research and the specific research that we did at our companies. The other really critical thing is being able to get the smartest person in the world in the room working on your problem. So successful companies and wealth of a nation come again from research, and they come from attracting smart people. And so if I can keep a graduate of Yale who's a foreigner in the United States, I can create 400 jobs by doing that.
Very important.
People have argued with me that, oh, I'm taking one job away. And what I try to explain is if that person, and I'll pick on somebody, Wolfgang Heinz, and this is somebody that built ION with me. He's from Namibia. He had been a postdoc at Yale, and they wanted him to leave. And by having Wolfgang, we've created 400 jobs.
Wow.
And that's one example. And I have it over and over again. So again, governments can be important. Research and allowing the smartest people in the world to stay in the country, or let me bring them in. Sometimes I read a paper and say, I can create a company, and I've created over 5. And I've created thousands of jobs, and I've created hundreds of millions of dollars of commerce. And it's all based on leveraging research that the government funded and getting the smartest people to work on the project. I never have taken away a job by bringing somebody from Namibia or England or anywhere else in the world here. What I've done is enabled me to translate that basic research into products that we could sell.
That's fantastic.
And so many people miss that.
I agree. Of course, there was a lot of scientists that came to this country after World War II from Germany that really helped create the space program. So a lot of people fundamentally know that, but it needs to be said because, I don't know, recently there was a lot of resistance to giving $1.1 billion for a research organization here in Connecticut. And I basically emailed all the senators who were involved saying, very good idea. I know that everybody's on a tight budget, but this is so fundamentally important to the economy of Connecticut to have bioresearch focused in this area.
I'm lucky enough to have gotten to know Jim Watson. Again, Jim Watson with Francis Crick gave us the basis of heredity. This was one of the greatest unsolved mysteries. Why do your kids look like you? It's that double helix and the ability for it to replicate that allows us to pass on those genes. When I talk to Jim Watson, what he likes discussing is the reason the United States is the center of biotechnology. Why do we have Amgen here, Biogen here, Genentech here? Is because during and after World War II, we brought all these scientists that were running away because of prejudice from Europe,
right.
and they came here. And it was these scientists that gave us the basis of our biotechnology industry. So we have to bring the smartest people here. We have to do basic research. That basic research allows industry to do development. So I don't do basic research. What I do is turn that into products. Mm-hmm. So there was research on transistors, and there was basic research on semiconductors that allowed the moon launch. I took all of that research and I invented a chip that would see chemistry. But if it wasn't for that moon project, there would have been no industry that makes chips for me to build on. If it wasn't for liberal immigration policies, we wouldn't have had Noyce, who is the father of semiconductors, immigrating here, or Andy Grove, who built Intel and ran away from that. So again, it's basic things. You can talk about these things at a high level, research is important, or you can make it personal. I wouldn't have my companies if I wasn't able to get smart people, keep them in this country, and I didn't have a research base to build on, and I didn't have grants. Because when you're starting a company and you're way out there, when we said we wanted to sequence everybody in the world, people laughed at us. They said, why would you want to do that? And so you couldn't get venture funding, but what you could do is you could get grants that said, we want to change the world and to code DNA fast. And so you do need that basic research before industrial research to be a foundation, and you do need those grants to be a foundation to really be a pioneer.
Wonderful. Well, we're almost out of time, but I'd like to ask your son Noah, what do you want to be when you grow up, Noah?
Probably a scientist.
Oh, well, that makes sense.
As I said, it's my children that have inspired me to do all of my work. When Noah wasn't breathing, I needed a DNA sequencing machine to read his genome. Genomes before that had taken 10 years and cost $3 billion, and I needed his sequence right at that moment, so I invented DNA sequencing. And it was Noah who inspired me that what I had done wasn't even good enough. So thanks, Noah.
Well, I'd like to thank you both for coming here today, and it was really a pleasure. And I want to congratulate you for the fine work you've done. I am very impressed with everything that I've ever read about you.
Fantastic, but I want to add one thing.
Sure.
As I said, it's important to support research. And for all of you that have degrees in engineering, computer science, or molecular biology, email me, because I build companies and I build products and we do good things, but only by getting the best people in the world. And nothing I have done has been done by me alone. It's been done because I've been able to bring in computer scientists, to work with a molecular biologist, to work with an engineer, to work with a doctor. And it's that team together that has allowed any of my success. And so please, if you're highly motivated and you're great at what you do, send me your resume. We're always looking for the best computer scientists, the best electrical engineers, the best molecular biologists.
Sounds good for the jobs that we need so badly. So again, thank you both very much for coming in. And that's our show for today.
Thanks.
Thank you.